Good morning and welcome back to Brodeur Land. We are still in week 5, but now we are on day 3. That's right. And today we're going to wrap up systems of equations. So far we've talked graphing, elimination method, and today we're going to finish up with substitution method. So all in all, let's talk about what today's learning intention is. Similar to yesterday, we're going to find solutions to systems of two linear equations algebraically, but using the substitution method. So let's come on over here. All right. So today, substitution method, we're going to take a look at 2 examples. Both of these examples appear on the 4 questions you need to do today. We're going to go through example 1 together. And example 2, I'm just going to kind of start for you to show you how to set up and then let you guys go at it for the rest. So let's go to example 1. Now, if you want to compare this with elimination method and the graphing method, you might be thinking, wait a minute, Mr. Brodeur. On graphing, we use y equals mx plus b, which was the slope-intercept form, but we have that. But then on the other one, we're using standard form like it was elimination, and standard form is something like ax plus by equals c. Now, that's weird. We use standard and elimination. We use slope-intercept form with graphing. Why is it all mixed up here? Well, this is a situation where you would use substitution because clearly you have a mixture of 2 methods and you would have to do a lot of moving to try to set it up to use one method or the other. With substitution, you don't have to do any rearranging. You could use the equations just the way they are right here. And this is what you have to do. First, you're going to look and see, do any of my equations have a variable solved for? Meaning, do any of my equations have a variable all by itself? And we do. That top equation has y already solved for. Y equals negative 3x plus 5. Now, some of you guys might say, well, Mr. Brodeur, there is a variable in there too. Is it really solved for? Well, that is true, but what we're looking for is y or x completely alone. Yes, y is completely alone. And what we're going to do is pretty much use the name substitution. We're going to substitute y in this equation with what y equals. So we're going to take negative 3x plus 5 and we're going to substitute y in there on that second equation. So some of you guys might be thinking, okay, Mr. Brodeur, I don't know. That might be an earful. I'm a little confused. What does that look like? So put it this way. Let's pretend like you're playing a basketball game, right? And usually in basketball, you have to sub out players. Players go to the bench, and then bench players come out to the floor. So let's say you have 5x minus 4y equals negative 3. What's happening is we got 5x minus 4, but we're going to sub out this y. So I'm going to keep it blank, but I'm going to put parentheses to say we are subbing out this y right here. And what we're going to replace this y is with what y equals up here. Y equals negative 3x plus 5. So it's kind of like that's where we get the substitution name. We look for what variable is already solved for, and we're going to substitute it with what it's equaled with. Now, we do not have any y's, we just have x's, which is exactly what we want because we want it all to be just one variable, so now we can solve. So what we're going to do is we're going to clean things up. 5x is good because it's just 5x, but now we have this negative 4 right here. And this negative 4, notice I didn't just look at 4, I looked at the sign that went with 4. We need to take that and distribute it into our parentheses, or what we just substituted in. So negative 4 times negative 3 gives us positive 12x. Negative 4 times positive 5 gives me negative 20. And then, of course, equals negative 3. That just kind of stays the same right there. And then we're just going to continue to clean up. Notice right here, I got like terms, so I'm just going to combine. 5x plus 12x gives me 17x. Now, some people might be thinking, Mr. Brodeur, why didn't you do inverse operations? Like, why wouldn't you subtract 5x to 12x? Well, that's only if I'm trying to move something across the equal sign. We didn't have to move these across the equal sign. They were already on the same side. So I'm just going to do exactly what it says right there. Bring down my negative 20. Bring down my negative 3. And now we have a two-step equation. Now I can go straight through and I can go about solving. So the first thing is I'm going to get x alone. What I need to do is I need to add 20 to both sides. Notice here I am doing the inverse operation because I had to cross over the equal sign. There I did not, but here I did. So I'm going to eliminate those. That gives me 17x equals 17 right there. And then last but not least, we just got to divide by 17 to get our x alone. And that gives me x equals 1. But remember, I know it's very, very tempting to stop right there. But just like with graphing, just like with elimination, we can't stop right there because we need our coordinates. Okay? So we have our 1 for x, but now we also have to find our y coordinate. Now this is going to be very similar to what we did with elimination. We're just going to take x equals 1 and we're going to just plug it into one of our original equations. It really doesn't matter. I guess I'll just plug into the top one. I just tend to plug into the top one, but if you wanted to plug into the bottom one, that is perfectly fine. So I'm going to bring down y equals negative 3x plus 5. Now what happens though is I want to take my 1 and I want to plug it right there for x. So what that really looks like is negative 3. We're substituting this 1 in for x right here. So that's why I put the little parentheses. I'm going to substitute 1 right there. And now we're just going to solve for y. So I'm going to bring down my y. Negative 3 times 1 gives me negative 3. And then plus 5. And then negative 3 plus 5 just gives me 2 right there. And that's, we got our 2. I'll drop that down right there. And that would be my solution. And notice right here, this would be what we would call a 1 solution because you only have one ordered pair, one coordinate pair, so that would be a 1 solution. All right, and then last, what I'm going to do here, like I said, this is your first problem, and I wanted to kind of go through one, but I did want to talk about this example. Let me just do this so that way we can kind of separate the two. I do want to talk about this one because this one has x equals instead of y equals, and I believe the other questions all have y equals except for this one. So I'm going to start this one off, but I'm going to let you guys finish this one and the other two. So let's start this one off. Same thing. I notice, ooh, there's one that's a slope-intercept form, and there's one that's a standard form. So since I have an equation that has an x or y solved for, where x or y is completely alone, I'm going to use the substitution method. So in this case, we have x. So that means down here, we're going to take what x equals and substitute it in. So what that means is I'm going to take this second equation. We're taking x out of the game right there. He's being subbed out. Everybody else is coming down. And what we're going to do is instead of x is going to be replaced by a substitute, or what x equals, which is negative 2y plus 3 right there. And then at this point, what we have to do, I don't have anything on the outside. I mean, technically I have a 1 right there, but if I went to go distribute 1, that would just keep it as negative 2y plus 3, and then plus 2y equals 3. Okay? And then right here, this one is actually interesting. So I think I might actually finish this one up just to kind of give you an idea of what happens here and to see if you guys can catch it. What you might notice right here, negative 2y and negative 2y plus 2y, I'm going to combine my like terms, but notice those get eliminated. We have 0y. Now that plus 3 is still there, and then we have 3 right there. Well, 0y is just 0, so 0 plus 3 is 3, and this comes into a situation like we had with an elimination. Remember with elimination, we talked about what happens when all of your variables go away. If all your variables go away, that means we cannot have one solution. That means we either have that infinite many solution or no solution. The question is, which one do we have? And if you remember, if this is a true statement, meaning 3 equals 3, that is true. That means you have infinite many solutions. Right there. So I kind of actually ended up doing 2 problems with you guys, but I couldn't just leave this one unfinished, especially it being weird, so I wanted to make sure you guys got that. Now, just a reminder, and we talked about this with the elimination, let's say instead of 3 equals 3, we know this one's infinite many solutions, but let's just make this up. Let's say you had 3 equals negative 5. Clearly, those are not equal. So if you got a scenario where all the variables canceled out and you were just left with numbers and it was not a true statement, remember that would be a no solution scenario. So if you had that, that would be, but of course in this one, it was 3 equals 3, so that would be infinite many solutions. So all in all, I hope this wraps up, helps you feel a little bit better, especially with substitution method. But also, hopefully this clears up any weird scenarios like infinite many solutions or no solution. But just let us know, let your teachers know. If you got any questions, send us emails. But until next time, Brodeur out. Peace.